Hey everybody, Mr. Van here, and welcome to Getting Started with Arduino. This is going to be the pre-lesson to the actual lesson because that sounds more educational, let's be honest. But more importantly, this is going to be giving you some vital pieces of information that's going to help you succeed in this class because I'm pretty sure you need to know how to access things so you can properly code. Alright, so we're going to be using the Arduino board. It's a small little development board, which means you can plug in different wires and sensors and then code it using a variant of the C language, or C++ language. Now, C++ is what's considered an industrial code language, meaning that it's used to, actually power things. If you've used something like Scratch in the past, where you have that puzzle-based, click-based, kid-friendly game, great, you've learned kind of some good understandings of coding, but you haven't actually gone into real coding, and that's what we're doing here. So an IDE is what's called an integrated development environment. Basically, it's a graphical user interface. It's a way for you to visualize and understand how to properly code without using binary. And that's very important. So when you've used Scratch in the past, you've used that GUI. That's just an IDE of the Java language. All it is. So to visit the Arduino IDE, go to create.arduino.cc, or if you have access to this presentation, if you're in the class, then you can access the slides, click on it that way. If you're watching this on YouTube, I've put the link in the description, so please check that description. Don't put a comment that's like, well, how do I click on it, Mr. Van? Go in the description. So once you're there, you're actually not going to get this page immediately. It's going to ask you to sign in. Sign in however you want. We use Gmail in our class, so use Gmail. Use your Google login. Use that single sign-on for Google. Then you're going to be given this page, and you're going to click on the box that has the giant red circle with the giant red arrow. Click it. Click Arduino Web Editor. That is what's going to get you started. Once you do that, you're given this page. Now this page, I want to break it down a little bit for you. Over here is your environment. This is where you're going to be coding, and we're going to go through in a second what all of this stuff is here. Up here, you have a check mark. That means to verify your code. So once you've written your code out, click the check mark, and it's going to verify it. Once it goes through, down here in this black area, it's going to tell you if anything is wrong, what it was. If it isn't wrong, it's going to be like, ready to upload. It says something more official. But you get the gist of it. If you messed up, it's going to say something like, line 8, colon, was expecting something. And then it'll tell you what it was expecting. So if you missed a semicolon, which is imperative that you use semicolons, it'll tell you that. But you have to actually read it. It's going to look confusing the first time. It's going to look overwhelming the first time it gives you an error. It's okay. Just read it. Try and figure out what it says. Then here, select board or port. You would actually click that and then select Arduino Uno. That's what you want. And then you do have the option to share your code out. Over here, you have different things you can do. So you can check out different libraries. So if you're working with a motor shield, you can go into your libraries. You can import the motor shield library. Basically, a library is pre-made code that goes in, and then you can call back that code when you need a certain function to run. So if you have a motor shield, you can call the motor shield code, and then from there, take what you need. You also usually get a little tab here that tells you what the code is, so you know what to code to go back. Or you can use the dreaded README file and learn about how to actually use it. You also have monitor. That's for serial monitor. That's something we're going to be getting into a little later on in this class, as well as preferences, which is really important because you can make it easier to actually read your environment. So if you click preferences down here, you can see you get this option for editor font size. You can change it from 14, so if you have a hard time seeing what's on the screen, you can actually click it, make it a larger font. You can choose between different themes. Maybe you don't like the light theme. Maybe you're a dark theme kind of person. Go for it. Don't mess with these. Don't mess with these, right? If you disable this one, especially enable autosave, and you uncheck it, and then your Chromebook crashes, then sorry, you made the decision to not autosave. Keep it enabled. That's the last I have to say about it. All right, so this is kind of a breakdown of what this area means. So you'll notice when your code, if we go back here, right, this was blank, all of these were blank, we had void setup, void loop, nothing in here. All right, so that first area, you can actually insert like paragraphs of text if you need to, if you're trying to give information, contact information, explaining what your code does, writing funny messages. I don't care what you put up there. You don't have to put anything up there. But that's what that area is used for. In fact, you can delete these from line 3 up to line 1, and your code will run just fine. Doesn't matter if it's up there or if it's not. But if you're creating a set of code that you want to share out, right? Maybe you've created a really cool Arduino device. You want to explain things or put your contact information up there. That's where you would do it, right? It's basically that first line that's like, hey, check this out. That's all it means. Next, if you have anything behind a double slash, that's what's called a comment. So you're going to see if you import code comments on certain areas, right? Those comments help you understand what you're looking at. It's also a good thing for you to get in the habit of when you write some code, put comments there, especially if it's a giant piece of code. Putting the comments will help remind you of what you're supposed to do. And we're going to be doing a lot of comments within our first bit of coding because I want you to get used to that and understanding it. Right? Anything that you put behind it, it's important that it's commented. Right? Or if you create something and you don't like that set of code but you want to keep it in there in case like it partially works or it breaks something, you can do what's called commenting out, which is just adding // in front of it on the line. Now, it's also important to note that Arduino IDE, it's very important that your spelling is correct. So if you're trying to call up an integer that you've created, say it's like light, L-I-G-H-T, and then you misspell L-I-G-H-T to L-I-H-G-T, your code won't work because it's calling back to that specific spelling that you've created. So spelling does matter. Capitalization actually matters, right? So if you have something that has a capital letter and then you call back to it later on, further down in your code, and you don't have the capital letter, it won't work. Keep that in mind. All right, then we have void setup. This area is just basically it gets your Arduino ready. It's getting the pins ready. It's telling it what it needs to do so it can execute everything in your void loop or other coding areas that you've created. Your void loop is the program. That's what we're going to be working in mainly, and that's what's going to run your program indefinitely or until you decide to turn it off. So the Arduino board itself. Now you can look at it in your kit if you would like to follow along, but just a quick breakdown, they do a good job on the board itself. This side, so if you're holding the board and looking at it like this, on your left side is all of your power stuff. 3 volt, 2 5 volts, and 2 ground. Analog, right? Analog pins, they allow you to actually set specifically like what's going on. That's incorrect. Sorry. Analog pins, they work more with like hard-coded hardware, stuff that doesn't need to be constantly reading. So if you're using something like a potentiometer, it's basically a twist knob. You use an analog pin for that because you're physically twisting it and you want it to be reading the changes there. Digital pins over here are for things that can automate themselves better, like lights or motor shields, stuff like that. And you can see you have digital pin 0 through 13. These are actually important as we get further on, especially if we start working with things like Bluetooth. Also down here, we have RX and TX. This is how you send data through radio waves. You have another ground over here, and then you have some I2C components. We're not going to get into I2C too much, but just so you know that they're up here. For our first coding lesson, we're going to be using 13 and ground. Keep that in mind, 13 and ground. We also have these guys over here. Don't worry about them just yet. We might get to something. So some terms to get you started, and we'll cover this in the next lesson. INT refers to an integer, and an integer is a term used to represent a number. So if I say something like INT, and then I use the phrase LED, so an LED light bulb, for instance, I can set that equal to a specific number. So then anytime I use the word LED, okay, that's calling back to a specific number. Basically, I've just created a representation for me to mentally remember things. Output means that you are wanting to send data out of a pen. Input means you're telling the board to be looking for data or basically electricity coming into the pen. HIGH, hi, it's all in capital. It's important to note. It's all in capital, so is input and output. Those, you need to note that. I specifically put them in capitals there. High means on, low means off. Pin mode means it's telling, when we write it in our code, that it needs to activate a certain pin. Okay, one of these over here, a digital pin. And digital write. Digital write is an easy way of basically saying that it needs to perform an action on the pin. You'll understand that more. Finally, semicolon. Add this at the end of every line of code that doesn't need to be extended, right? Think of it this way. A semicolon is a period. A period means to stop that specific sentence. In coding, or at least in Arduino, if you do not have the semicolon in there, that's telling the, if you don't have it, it's telling the IDE when you're running the program to keep reading and keep reading and keep reading. The semicolon is what stops that and tells it, okay, move to the next object. If you miss out on the semicolon, you will get errors in your code when you try to upload it. All right. That's all I have for getting started. 12 minutes long. I guess that was a lesson, maybe. We'll call it pre-lesson. If you're watching this, it's mainly because you weren't in class when we did this, or you're wanting to relive it, or maybe you've just found this channel and you're wanting to learn to code with Arduino on your own. Anyways, I hope you enjoyed this video. Hope it was easy to understand. And check out the next video, which is going to be our first coding project, which is like everyone's first coding project on Arduino, but it teaches some excellent concepts. So check it out. Also, give me the views. I think it's a good thing. Get more views on these. All right.